Okay, so we're gonna do this the bone dead way, but at least it works. So we are gonna do a for loop, old style for loop. So we have an iterator. What we want to do is we want to start with the first chunk. We want to run this as long as it's not the last chunk. And we're not going to have any specific increment because we want to do this little bit sneakily. So if we can get this in, we have our render chunks. If we can find this, okay, so now we need to double dereference the iterator. So if this chunk here is in our render chunks, that means we can count it more than 0 times. We want to keep it, so we just move the iterator forward. If not, and this is where it gets interesting because there's some weird fun stuff with iterator invalidation. So let's have a look. Here at erase, invalidates iterators and references at or after the point of the erase, including the end iterator. So what I'm reading that is it does not reallocate memory, which is what I wanted to know. So what we might be able to do is then go chunks.erase. So this is not on it. We want to erase this one, but only this one. So we're going to try that. That should be the bone dead simple way of doing it. Hopefully nothing goes wrong here. So we're going to transition over and let's take a look. Reload. It starts popping in. Let's move forward. Oh, it seems to be generating No, it's not generating reasonably. Something really... I really, really, really don't get this. So that chunk there should not be popping in that close. There's something really, really strange going on here. It looks like some of these chunks are getting wrong positions. That seems really crazy. I don't really get this. That one, please. Oh, and Toladar, thanks for the follow. Just notice that now. Now, if someone could tell me what the hell is going on here, I'd be really happy. But somewhere I'm doing something very wrong, I think. I'm turning X, Y, Z. Okay, let's assume that this syntax isn't valid and something's fucking up here. So the sure way of doing this is like that. Thanks, man. Appreciate it. Comes with doing this for longer than I care to admit, and a lot of practice. Cool. So we've got that going and set up. And these are just, yeah, they're just the ones that I pass in. So that should be correct. So it was a building, so we're going to try that again. Okay, did that? No, it didn't. This is awfully strange. It really, really looks like I'm ending up generating stuff or rendering stuff in weird places. Now, an interesting question here is this not what I think it is, and is it in fact more sort of like the chunk renderers doing something wrong? Because that is also a possibility. Yeah, Panda, you know I'm famous for my one-liners. I don't have that many in this project, luckily, because then it'd be totally unreadable. So let's assume the problem is the chunk renderer, because that's not entirely impossible. Because I'm getting the chunk at the relative position there, which it really doesn't want to follow. When we have a chunk, we have this get relative position, which takes an IVEC, which is the center chunk, and then it gives me a offset to that, which seems to be fine. Taking my coordinates x, y, and z, subtracting center coordinate from that, and then multiplying by the size. That should be correct. That is correct. Again, I'm gonna assume that this syntax might not work as well as I think, and we're gonna do that instead. So I return that. We set up the local model transform. We bind that in to our model transform here. We have just the one matrix. We don't want to do any normalization on it. Then we bind it and we draw that using unsigned shorts at offset 0. If my chunk version is not the version of the chunk that I'm using, and this chunk is a constant reference to a chunk, which is the one I've been bound to. This which may or may not exist at this point, because I'm not really keeping those two lists in sync. let's have a look at the GLES renderer. So I'm starting to formulate a hypothesis here. Because our chunks don't live forever, they I guess, flicker in and out, or what you want to call it. They change over time. What might happen is that, well, this is kind of weird because it's not necessarily the thing I'm thinking about would happen if we reuse a chunk later. Because of course, what would normally happen if you have like memory corruption is that you'd segfault, get a segmentation fault, or on Windows it's a general protection fault. But of course, because we're not actually strictly accessing memory in the same way when we're in the browser, it can sort of survive it. So what I'm thinking might be happening, or what seems likely to happen, is that as we go away from stuff, we kill off a lot of old chunks, but the chunk renderers still maintain a reference to that chunk. And if another chunk is recreated at the same position, we'll return the same chunk renderer for that position, which is a bad idea. Because that means that in that way, because if we're returning a chunk renderer that references a chunk that no longer exists, is probably the reason why we're getting weird results like this. Why it exactly results in nice big blocks and stuff, I don't quite know. But it will mean that also the position of it is completely crazy, which will also give wrong results. So I'm thinking that's probably what's going on here. So let's have a look at what we might do about that. So one thing we could do is we could track all the chunk renderers that are asked for and then remove the ones that are no longer being used. That means we would then recreate them later. It's not perfect. The alternative would be somehow to say, to register a sort of callback on the chunk, saying that so that the chunk renderer is bound to the chunk. So when the chunk dies, the chunk renderer dies as well. Would be a way of doing it. That might actually be the most interesting way of doing it. Kind of requires that we do some callbacks so that the world can call back into the renderer and say that a chunk has disappeared again. But that might actually be an okay idea to have, so that we can basically both notify the renderer that a chunk has appeared and that a chunk has disappeared. Yeah, I think that actually sounds like a good idea. So what we're gonna do is we're gonna, in addition to the world, we're gonna introduce the idea of a chunk listener. So a chunk listener is going to be an abstract interface here, which is gonna have chunk added. And it's going to take a const chunk reference, and this is just going to be null, and then we're going to have a void chunk removed. So we have these two functions, and then we are going to have on our world, we're going to have a standard vector of chunk listener pointers. Listeners or chunk listeners. chunk listeners. Chunk. I think I spelled that right for a change. And then I want to have a void chunk listener add. So that's going to take a chunk listener pointer and do something with that. So what we are going to want to do here is we are in our main function here. When we create our renderer here, we have our world as well. So on our world, we want to add a chunk listener, which is going to be our renderer. So our renderer will be notified when chunks get added and removed. And we're going to call .get on that because it's a unique pointer and we just want pointer. Yeah, GLES renderer is not compatible with chunk listener because it's not a chunk listener yet, but it will be in a moment. So we are going to include the world here. And then GLES renderer is going to inherit from chunk listener. And then again, we are going to use an unordered map based on chunk pointers because that will be a lot easier to work with now. Oh, yeah. These are virtual and virtual, so that we can overload them in our chunk listener. So our GLES renderer, okay, we're gonna go out here, renderer. So in addition to having all of this, we have the chunk added and chunk removed callbacks here. We've got all of that. Now over here we have all of this fun stuff. We're going to find that. If it doesn't exist, we are going to insert it. So what I'd like to do here is go for GLES renderer, chunk added. It's not going to do anything for now, but chunk removed. When a chunk gets removed, we are going to try and find it, see if it exists, and if it does exist, that is, we don't hit the end of it, we're going to remove it. So in that case, we are going to go for our chunk renderers here. Dot erase. And we want to erase that renderable. Indirection requires point. Oh, wrong way around. I need to take a pointer from it, not dereference a pointer. So I want the address of. And I can see that because we need to do a little bit of const work here, the GLES renderer, these are constant chunk pointers, so we can't modify the chunk, but we do know the pointer and we can find the renderer associated with it. So we have an unresolved symbol in that we can't add the listener at the moment. We need to implement that function. So let's just take a look at the world here. Which order did I do that? So it comes afterwards. So what I'd like to do is I'd like to go for the world chunk listener add. Then we are going to say we have a chunk listener list. I want to push back onto that this listener. So now at this point up here we've added a chunk. In fact, I'm going to want to grab a reference to it. Call it chunk. So we have a reference chunk. And that's first dereference the iterator and then the pointer. Then for every const auto, no, not const, because we actually want to change state. For every listener in the chunk listeners, which is also something I need to do here, I want to call that listener's chunk added with this chunk. There we go. Now up here, we're going to be removing a chunk. So what I need to do is I need to double dereference this iterator, called chunk removed. This chunk is no longer valid, and then we remove it. Now we actually get callbacks. Remember, reference type chunk is not a pointer. Did you mean to use dot? Yes, indeed I did. So because this is a reference, we use a dot instead of the arrow for pointers. Let's try and transition over and see if this actually worked. Because that's always the exciting point. Does it work? So far, so good. I'm not getting any weird artifacts. And I am getting stuff deleted behind me. So that seemed to work, which is great. So now we in principle have infinite terrain. Well, I say infinite, practically infinite. Something like 32 billion blocks in every direction. I think that practically qualifies as infinite. So yeah, that's pretty cool. But I unfortunately think that's all we're going to have time for today. I unfortunately have to get up really early tomorrow. So I need to get some sleep by now. Yeah, it's practically, you're not going to reach the end before you get bored. That's true. Next week, Saturday, I'm hoping to stream, but I get off a train at 7 in the evening, and I have to get home from that. So the earliest I'm going to be streaming at is like 8, might be 9. We might move it to Sunday instead, but I'm definitely planning to stream next weekend as well. Hoping to do it Saturday, but it might end up being Sunday. I'm sure you will, Panda. You've always been the obsessive one about getting to the end of the world. I think next week what we're going to focus on, because I never got around to doing it last time I said so, but next week we're going to focus on trying to get this online somewhere so that people can try it out and play with it. But that's just an idea at this point. For now, I'm gonna sign off, and yeah, I'll see you guys somewhere sometime. Have a great Saturday evening / night / whatever it is in your local time zone.